Second thing we will discuss, cyclotron. Cyclotron is a device used to accelerate charged particles like protons, like alpha particles, like deuterons, like ions, to acquire high energy. And it was invented by the two scientists. One is E.O. Lawrence and M.S. Livingstone in 1934. Actually, this high energy particle is used in different nuclear reactions, right? In different nuclear reactions, there is we have to bombard a nucleus with very high energy particles, and that high energy particle can be produced with this instrument or with this device. Now you have to assume or you have to imagine the setup. Have you seen the flat container of creams? Different cream? Flat container?
Yes, sir.
Like Nivea or like the shoe polish. You have seen that?
Yes, sir.
Okay. Now, just cut that container geometrically. What will you get? You will get to D. This is D, right? D-shaped container. But it is a hollow container. 2 D-shaped hollow container, right?
Yes, sir.
Okay. Now, the cyclotron consists of 2 hollow D-shaped metallic chambers, D1 and D2. Let us draw these D-shaped containers. What is this? This is a D-shaped container. You can draw like this. These are the 2 D-shaped hollow metallic chambers separated by a small gap. Clear? This is D1 and this is D2, and these 2 containers are called D. D. There are 2 D's. One is D1, another is D2, separated by a small distance. Clear? A charged particle is at here on the gap between the 2 D's. A small charged particle or a charged particle is placed in the place between the 2 D's. These 2 D's are connected to a high frequency oscillator, providing high frequency electric field across the gap of the D's. We connect a high frequency oscillator across these 2 D, which provide a high AC electric field. That means there is an electric field connected to these 2 D's of high frequency, AC electric field, right? Now particles inside the D's when the particle is inside the D, will it experience electric force? We have given an electric field, right? We join these two D with an AC voltage. Now when a charged particle is inside the D, will it experience force due to the electric field?
No, sir.
No, because the D's are hollow and metallic. Therefore, it is shielded from the electric field we have discussed in the electrostatics. But the magnetic field acts on them and they move in circular orbit. If there is a magnetic field, now here is a magnetic field which is perpendicularly out of the board. Clear? There is a magnetic field. The total region, there is a magnetic field which is out of the board, perpendicularly out of the board. Therefore, the charged particle, this charged particle, when let us say this is a positive charged particle and at an instant, let us say it is a negative voltage. The voltage of this side is negative. Then it will attract towards this and it will enter the region of D inside D. Clear? Then when it will go to or go inside the D, it will not experience electric force. Now there is a magnetic field in this region also. Therefore it will experience a magnetic force, and that force, due to that force, it will rotate. Clear? It will move in a circular path. Let us say comes here. Now the time taken by the particle to come here, let us say it is T by 2. If capital T is the time period of the rotation or time period of the circular path, then the time taken by the particle to cover the hemispherical path, that is to cover the half circle, is T by 2. And in this time interval, if the polarity reverses, that means it was negative in the first initially, now it is negative. Then the particle will attract in this direction. There is a force, there is an electric force when it reaches at this point, right? And which accelerates the charged particle. Accelerate means its velocity increases. If its velocity increases, then the radius of the circular path will increase. Therefore, like this, it will rotate like this. That is, its path will be spiral. Is it clear? Every time the particle moves from one D to another, it is acted upon by the electric field. The sign of the electric field is reversed alternatively in tune with the circular motion of the particle. This ensures that the particle is always accelerated by the electric field. Each time the acceleration increases the energy of the particle. As energy increases, the radius of the circular path increases. So the path will be spiral. The whole assembly, this whole assembly is evaluated to minimize collision of the charged particle with the positive ions or different charged particles inside. If there is air, then this charged particle will hit the air molecule and it will produce the charged ions. Clear? Let positively charged particle such as proton are released at the center. They move in a semicircular path in one of the D's, and arrive in the gap between the D's. Clear? Gap between the D's in a time interval t by 2. In a time interval t by 2, t is the period of revolution. When polarities of the D's have been reversed so that the charged particle is further accelerated towards the other D. Okay? This t by 2, which is the, what t is the time period of revolution, is so adjusted that in this time interval the polarity of the electric field reverses. That means, for that case, we know this is the centripetal force required to rotate the particle, and this will be equal to QVB, which is the magnetic force which provides this centripetal force. mv square by r is equal to QVB, and for that case r is equal to, we get, already we have discussed this, mv by QV, and therefore the time period t is equal to 2 pi r by v, that is 2 pi by v into r is mv by qv, which gives 2 pi m by qv, and therefore the frequency of the particle, that is in unit time the number of revolutions is nu c is equal to 1 by t, which is equals to qb by 2 pi m. This is the frequency of the cyclotron, that is this is called the cyclotron frequency. This frequency is called the cyclotron frequency. The frequency nu a, that is the frequency of the applied AC voltage, is adjusted so that the polarity of the D's is reversed in the same time that it takes the ion to complete one half of the revolution. This requirements, nu A is equal to nu C. Nu A is the frequency of the applied voltage and nu C is the cyclotron frequency. This is necessary to accelerate the charged particle. Clear? And this condition, nu A is equal to nu C, this requirement is called the resonance condition. And now if the V is the voltage, if V is the voltage difference between the D's, then increase in kinetic energy, increase in kinetic energy is QV. Q into V is the increase in kinetic energy each time the particle cross from one D to another D. From this D to this D, when charged particle arrives at this position, it will attract by this electric field and its energy will increase. The amount of energy increases Q into V. Again, when it reaches this, again it will increase the energy Q into V. Clear? And increase in energy increases the radius of the circular path. The radius of the circular path go on increasing, right? Each time their kinetic energy increases. The ions are repeatedly accelerated across the D's until they have the required energy. When they acquire that amount of energy, then the particle will be deflected by a magnetic field and leave the system. There is a magnetic field here to deflect the particle. Otherwise, it will rotating. It cannot leave the system. there is a hole in the D, and in that position we have to apply a magnetic field to deflect the particle from the circular orbit. Now, if at the time of exit the radius is capital R, at the time of exit radius is capital R, then capital R is mv by qb, or we can say v is equal to qbr by m, and therefore the energy of the particle is half mv square, which is half m into q square b square r square by m square, that is q square b square r square by 2m. This is the energy of the charged particle. From here you can get highest energy. You can get highest energy of the particle. The operation of the cyclotron is based on the fact that the time of one revolution of an ion is independent of its path or of its speed or radius. See here, what was T? T was 2 pi m by qb. This is independent of radius of the circular path and also independent of velocity of the charged particle. Clear? That's why whether it is traversing higher radius, time is same, and that's why whenever it reaches one end of the D, it will accelerate. Clear? It doesn't change the time period. The cyclotron is used to bombard deeply with high energetic particles and resulting nuclear reactions. It is also used to implant ions into solids and modify their properties, or even synthesize new materials. It is used in hospitals also to produce radioactive substances, which can be used in diagnosis and treatment. Now, there are some limitations of cyclotron. First thing is cyclotron cannot accelerate uncharged particle like neutron. Clear? Number one, you cannot accelerate neutrons. And neutrons are mostly used in nuclear reactions. Second thing, electrons cannot be accelerated in cyclotron because of their very small mass. We know from the theory of special theory of relativity, that the mass of a particle m is equal to m0 by 1 minus root over 1 minus v square by c square. A particle of mass m0, that is rest mass m0, moving with velocity v, will be m is equal to m0 by this. That means if velocity changes, mass will change. Mass will change, right? C is the speed of light in vacuum. m0 is called the rest mass. That means when particle is at rest, mass is m0. Now, if the particle is moving with velocity v, its mass m will be m0 divided by this. Clear? Now, if mass changes with velocity, then T will change. That is, time taken by the ion to describe semicircular path depends upon the mass and increased mass. Now see here, mass increases. Increased mass will not allow the ion to arrive the gap between the D's exactly when the polarity of the disk is reversed. Nu A is fixed, applied frequency is fixed. Clear? That means the time required to reverse the electric field is fixed, but the time required to cover the semicircular path is changes. Therefore, when it will come to this point, it will not attract. The time required to cover the semicircular path is changes. Hence, there will be no acceleration. And if there is no acceleration, its energy will not increase. This is the difficulty in this cyclotron. And since mass of the electron is very less, then its change will be high. Its change will be high. That's why, especially electrons cannot be accelerated by using the electron cyclotron.